Hi guys, welcome back to our digital VLSC channel. Hope you are all good. So from this tutorial onwards, we will discuss about sequential circuits and their applications. Mainly we discuss about latches, flip-flops, counters and registers. So previously we discussed about combinational circuits such as encoders, decoders, multiplexers, demultiplexers, adders and subtractors. So we will see sequential circuits from this onwards. So let us see about SR latch using NAND and NOR gates and its circuit operation and its functionality using truth table. So before going to learn about SR latch, first we need to know about what is latch. So latches are basic storage elements that operate with signal levels, not with signal transitions. Firstly, you need to know what is meaning of signal level. So this is called a signal level. This is called one level and this is called another level. Let us assume this as 1, this as 0. So these are signal levels. So the output of latch always depends on these signal levels. And signal transitions are these things. The signal going from low to high or high to low is known as signal transitions. So mainly flip-flops depends on signal transitions, whereas latches depends on signal levels. So that's why we call latches are level triggered, whereas flip-flops as edge triggered. And also latches store a single bit of information and holds its value until it is updated by new input signals. Moreover, latches are used in digital systems as temporary storage elements to store binary information. And also they are built using digital logic gates such as AND, OR, NOT, NAND and NOR gates. First, we will discuss about SR latch using NAND gate. So this is the circuit implementation of SR latch using NAND gate. So let us see its functionality using truth table. S, R, Q and Q bar. When S is 0 and R is 0, this is the first case. First, you need to know that NAND is sensitive to 0. NAND is sensitive to 0. What's the meaning of NAND is sensitive to 0 means if any of the input to the NAND gate is 0, irrespective of other input, the NAND output is 1. So here Q becomes 1 and Q bar becomes 1 irrespective of another inputs. Now these inputs act as don't cares. What are the outputs of Q and Q bar? 1. But is it valid case? No, it's not a valid case because always Q and Q bar are complement to each other. So when S is 0 and R is 0, when SR latch built using NAND gates, this state is known as forbidden state. Okay, now let me erase this. When S is 1 and R is 0, this bottom NAND gate is sensitive to 0, so it gives output as 1. If this output goes to here, 1 into 1 is 1, 1 bar is 0. So Q0 and Q bar as 1. Now Q is 0. So at this time, SR latch is in reset state. When S equal to 1 and R equal to 0, SR latch is in reset state. Now the other input, S0 and R1. S0 and R1. So the top NAND gate is sensitive to 0, so it gives output as 1. If it comes here, 1 into 1 is 1, 1 bar is 0. So Q is 1, Q bar is 0. So at this time, Q became 1. So latch, SR latch is in set state. When it will become set, when S is 0 and R is 1. Now the last condition is S1 and R1. So S1 and R1. Now we will assume previous output values of this latch as 1 and 0. Now we will get the next state output values. So 1 goes to here. This is just an assumption. 0 goes to here. So this is sensitive to 0. It gives output as 1. Here the bottom NAND gate 1 into 1 is 1 and 1 bar is 0. Now what you observed is next state is equal to previous state. In this condition, SR latch act as memory, or you can say SR latch is holding its previous output value. So it is acting as memory when S1 and R1. So this is brief description about SR latch using NAND gates. Now we will see SR latch using NOR gates. S, R, Q and Q bar. So when S0 and R0, S0 and R0. So we will assume previous output values as 0 and 1. Just this is an assumption. You can keep 1, 0 or anything. Now next state. So when 0 comes here, 0 plus 0 is 0, 0 bar is 1. And 1 goes here, 0 plus 1 is 1, 1 bar is 0. So what you observed is next state is equal to previous state. So at this condition, the SR latch using NOR acting as memory when S is 0 and R is 0. So it is opposite to previous condition. I mean when SR latch built using NAND gate. And now S1 and R0. S1 and R0. And you need to keep it in mind that NOR is sensitive to 1. NOR is sensitive to 1. What's the meaning of NOR is sensitive to 1 is when any of the input to NOR gate is 1, irrespective of other input, it gives output as 0. So here Q bar becomes 0. Now Q bar goes to here, that means 0 goes to here. 0 plus 0 is 0, 0 bar is 1. That means Q1 and Q bar 0. So now latch is in set state. When S1 and R0, latch is in set state. Now the other condition, S0 and R1. Let me erase this. Now S0 and R1. This latch is, sorry, this NOR gate is sensitive to 1. So it gives output as 0. Now if 0 comes here, 0 plus 0 is 0, 0 bar is 1. Q0, Q bar 1. So as Q became 0, the latch is in reset state. Now the last condition is S1 and R1. As I said, NOR is sensitive to 1. This NOR and this NOR both are sensitive to 1. So both give output as 0. Is this a valid case? No, it's not a valid case because Q and Q bar are always complement to each other. So this case is known as forbidden case. We should never consider this type of inputs. And this is one of the drawback of SR latch. Okay, so this is about SR latch implementation using NAND and NOR gates. If you really liked this video, please share and subscribe to our Digital VLSA channel. Thank you. Bye.